skill training video has been produced by Semker in collaboration with PSSC and CNK. This video is aligned with the job role Supervisor Streetlight Installation and Maintenance, QP code PSS/Q2101, NOS code PSS/N2101. We are now going to learn the step-by-step procedure for inspection and testing of streetlights and associated equipment. First, we will know the need of inspection and testing of streetlights and associated equipment. 1. Inspection helps us evaluate the condition of equipment, machines, parts of the streetlights and electrical system. 2. The purpose of inspection before maintenance is to determine what tools, materials and labor are needed to keep them in good working condition. 3. Maintenance inspection is a process of evaluating the condition of equipment or machines. 4. With the help of maintenance inspections, one can identify minor issues before they turn into costly repairs. Inspections ensure that machines are working correctly and help prevent equipment downtime. For the inspection of streetlights, we mainly do following type of inspection. 1. Safety inspection. In this kind of inspection, we are checking streetlight foundation is proper or not. Nut and bolt tightened properly and earthing of streetlight pole is proper or not. 2. Fault finding through inspection. If any fault arises in streetlight, then through the inspection, we will find the fault location. 3. Lighting inspection. In this kind of inspection, we will find that light fixture wattage is proper or not and giving proper illumination in that area or not. 4. Electrical control panel board inspection. Here we will inspect the streetlight pole control MCB and timer for automatic switching on and off, that it is working properly or not. 5. Earthing inspection. Here we will inspect that earthing wire properly connected with light fixture or not. For inspection of street lights, the inspector's responsibilities are mentioned below. All street lighting systems installed shall require an on-site inspector to oversee the installation. The inspector shall see that the street light system is installed as per the installation specifications, construction, and material specifications. Inspectors are required by department engineer to use the current inspection checklist for street light construction and electrical testing forms. The completed forms shall be submitted by the inspector to department engineer for street light pole installation history. The inspector shall request to department engineering for inspection service before a final connection to main power supply distribution board. If a problem is detected with the circuit, then department engineer will not give permission to energize the circuit. The inspector must make corrections and reschedule the final connection. The inspector shall not open handholds or pull boxes on a circuit that has been energized even if the circuit is currently de-energized. The inspector shall contact the department engineering associate when a subdivision is ready for inspection. For new circuits. 1. Before the circuit is energized, the inspector shall inspect the installation and prepare a punch list. When the repairs are made, the inspector shall notify the inspection service. 2. The inspector shall assist the engineer in accepting the light system by opening the controller, pole handholds and pull boxes so that the wiring can be checked for correctness. 3. Connecting a new circuit to the main power supply. After the engineer approves the pole wiring, the engineer shall schedule a connection for main power supply to the controller with the cable connection, which will be done by the contractor at the pole. Engineer may recheck the controller for correctness before tying into the main power supply. Now we will discuss the step-by-step procedure for the testing of a system or various types of parts of street light installation. Testing of the system. In electrical testing, the most basic form of testing is by applying a voltage or current to a circuit and comparing the measured value to an expected result. Electrical test equipment verifies the value and logic behind a circuit. Each piece of test equipment is designed for a specific application. Heightened reliability and safety concerns have resulted in new maintenance programs and techniques. Every year, additional pressure is also put on operations and maintenance managers to provide a higher level of power system safety and reliability at lower costs. The greatest difficulty for many of these managers is to design, customize a comprehensive preventive maintenance (PM) program. Testing an electrical installation. Here a visual inspection is carried out first to confirm that permanently wired electrical equipment is not visibly damaged and compliant with the safety requirements. Test the supply across the on-off switch. Now when you switch on or switch off a street light and nothing happens, you have to think about what could be wrong. Let us try the simplest solutions first. Make sure the bulb is good and is properly fixed. Also make sure that the circuit has power, has not tripped its circuit breaker or blown its fuse. When one of these issues is not the problem, it could be a bad switch, especially if the switch is old and or feels a little loose. There is a sure way to test a light switch for failure. It requires removing the switch from the circuit and testing it. Test across all joints. Check the wire. The wiring defects include bad solder joints, faulty crimps, pin contact contamination, improper wire gauge, and stress extruded wire. Testing fixtures and other parts. Tests performed on fixture and other parts are circuitry check, lighting, installation, equipment and appliances, and any other tests that are considered necessary to meet the design intent. So with physical inspection and continuity testing, we can confirm whether fixtures and other parts are in working condition or not. Continuity of cable. Continuity testing of protective conductors is normally carried out with an instrument able to generate a no-load voltage in the range of 4 to 24 volt DC or AC with a minimum current of 0 to 2 ampere. The most common continuity test is to measure the resistance of protective conductors. Polarity test. Polarity test must be done to verify that all such devices are connected in the phase only. Incorrect polarity results in parts of an installation remaining connected to live phase conductors, even when a single pole switch is off or an overcurrent protection device has tripped. Now you're watching, we are doing polarity tests. First, we have to ensure that power supply is in off condition. With the help of a multimeter, we are checking terminal voltage. Voltage showing 0 volt, which means there is no voltage across the terminal. Now we are removing the light fixture and laying wire from phase terminal of light fixture up to switch terminal. Then between phase wire and switch incoming point, we will see continuity. As we are seeing when miniature circuit breaker MCB is on, then it is showing continuity, and when it is in off condition, it is not showing continuity. Means polarity is proper. Insulation resistance. The insulation integrity is critical to prevent electric shock. It is generally measured between live conductors and between each live conductor and earth. You're seeing we are doing insulation resistance test between phase and earth at 250 volt DC. We have connected the mega red probe with red color phase wire and the mega black probe with pole body. Now we are selecting mega at 250 volts and pressing the test button. Value coming around 5 gigaohm. Now we have connected the mega red probe with black color neutral wire and the mega black probe with pole body. Now we are selecting mega at 250 volts and pressing the test button. The value coming more than 5 gigaohm. The above value shows that insulation resistance is good and the circuit is fault-free. Separation of circuits. The separation of the live parts from those of other circuits and from earth should be verified by a measurement of the insulation resistance. The resistance values obtained should be identical to the values mentioned previously, with all appliances connected as far as possible. So the system function test follows component and equipment test using the various techniques listed above. Functional test. All assemblies such as switchgear and control gear assemblies, drives, controls and interlocks should be functionally tested to show that they are mounted, adjusted and installed in accordance with the relevant requirements of the standard. Protective devices must be tested to check whether they are properly installed and adjusted.